So a very simple differential equation that comes from Newton's second law of motion, so that is F equals ma, is the situation when the acceleration as a function of time is just constant given by gravity. So in this situation, we'll take our dependent variable y to be the position of the object at time t, and since we're dropping vertically, the position will be the height. Then the first derivative of position with respect to time is velocity, so y prime will be velocity. And the second derivative, so the rate of change of velocity, is acceleration. So let's take a look at what we've got then. So now we've got that m times acceleration is going to be the force, but the force is going to be mass times gravity because gravity is constant. And so we can just cancel off those m's, and we're looking at y double prime equals g. So now, since the dependent variable is isolated over here, in order to solve for it, we can just integrate. There's no y's or y primes appearing anywhere else in the equation. So if we integrate once, we get y prime equals g times t plus some constant of integration. And if we integrate, again, then we get gt squared over 2 plus c1t from integrating the constant, and then we get a second arbitrary constant of integration. Now, typically, the ODE would come with initial conditions, and since this is a second order equation, so maybe just highlight the fact that it's a second order here, we would need two initial conditions. So we'll have an initial condition for the position, and we'll have an initial condition for the velocity. So in that case, let's see what happens when we go to solve for the arbitrary constants c1 and c2. So let's see. So we can evaluate y prime at 0. And on the one hand, we have v naught, because that is the given initial condition right here. And then on the other hand, we have that this is going to be equal to g times 0 plus c1. And that one we get by evaluating this one right here at time t equals 0. So that gives us this one. And so then we can solve this equation. This one just says that v naught is equal to c1. So now we know what c1 is, and we have our updated formula, y equals gt squared over 2 plus v naught t plus c2. And now we can use our other initial condition over here and say, okay, if we evaluate this, we at time 0, y of 0 is going to be g times 0 squared over 2 plus v naught times 0 plus c2 by evaluating it at t equals 0. And on the other hand, we have that this is going to be equal to y0. And so looking at this latter equation from left to right, we see that c2 is equal to our initial position, and so that gives us that y as a function of t is given by gt squared over 2 plus v naught t plus our initial position y naught. So we won't do a whole lot with this equation through the remainder of the course, but since it comes up in pretty much every first year physics mechanics course, I figured we'd just derive it real quickly.